Hello all, welcome back to our channel. So in this video, we will talk about parallel termination in high-speed designs. In the previous video, we have talked about the series termination, how it is used, in what are the advantages, disadvantages of series termination. So now we will talk about the parallel termination. So parallel termination is again, it is also a simple termination technique like the series termination. This termination is done at the load side, whereas we have seen that series termination is done at the source side. This termination is like as you see in the image here, near the receiver, that means at the load side, the trace to the trace there is a pull-up that is added that to the logic levels that are being used for the driver and the receiver, or it is pulled down. So either the parallel termination could be a pull-up or a pull down. There are advantages and disadvantages of using pull up and pull down. We'll talk in the next videos, but this is how a parallel termination is used. And parallel termination resistor is calculated such that the resistor that is connected is equivalent to the impedance of the trace that is laid out on the PCB. So how that works is, whenever the signal flows from source, that means the driver, to the receiver, the signal that is reflected back will be absorbed by this particular termination resistor, and that meant there are no further reflections down the trace. So because the resistor is properly matched, so all the reflections are absorbed, and this will not in turn affect the signals that are flowing from the source. Whereas in the series termination, we have seen that the entire signal that is reflected from the receiver flows till the termination resistor that is placed near the source. Whereas here, as the termination is near the load, the signal gets absorbed near the load itself. And then so we were talking about this, right? Which combination is the best? Whether we have to use pull up or whether we have to use pull down. So we will use our basic circuit understanding to explain this. We know that whenever a resistor is pulled down, that means the current gets synced through this resistor to the ground. So this is like a passive kind of thing, right? It only sinks. It cannot help to provide any current. Whereas if you see here, this is a pulled up scenario where the source VCC can provide the current through the pull up to the channel. So in this scenario, we can say that this particular pull-up, when it is placed, helps to aid in providing the current and shares the load with the source. So that meant you are going to have a little load on the driver compared to the down scenario, because here we are like driving the entire current, we are sinking the current, whereas we are trying to source here. So compared to both these techniques, pull-up is always a good scenario. But again, pull-up has its disadvantage. We will talk about it. So now when we say we are sinking the current, or we are going to drive some current onto the channel, definitely there is a power consumption that is associated. So if you have your circuit which is driven by some battery, definitely power consumption from these particular resistors introduced will be a additional burden. And so in a battery scenario, this may not be a preferred technique. And then whenever there is a resistor that is connected from the channel, that means you are introducing an additional trace from that particular point to the resistor. So this is like a stub that is added to a specific channel that is routed between driver and receiver. So stubs are not at all a permissible ones in high speed designs, right? These change the impedance a little. There could be that stub which could degrade the scenario. But anyway, during the reflection from the receiver, the signal would be absorbed, which is helpful, but that stub is going to play its role in changing the impedance. And then the signal degradation. So because there is a pull-up that is associated, example, take a pull-up scenario. So this pull-up scenario would definitely cause the degradation of the signal, and you are going to see a worse scenario even though you are trying to help the signal to get better. So how it is going to worse the signal is what we have to know, right? So now when you, let us assume a scenario where you have a resistor pulled down to ground. Now when you take a receiver, definitely receiver will have some capacitance to ground, right? That is what we call load capacitance, and which is part of all of our data sheets. So this specific pin capacitance is parallel with the resistor that is there. So that means these two form a RC circuit to ground, which means they are introducing an additional delay which is calculated by the time constant value RC. So you have an additional delay on the signal introduced by this, which meant when we talk about delay, we are talking about the slew rate of change of voltage with time. So the slew rate gets worse because of this RC scenario. So that is one disadvantage that we see. So and then you need to select the proper resistor, which is a very important criteria. In the layout, we need to place this resistor properly. Selecting the VCC voltage is very important. You have to select the VCC such that it is compatible with the logic levels at which source and the receiver operates. So even though in parallel termination we have two different options, which is one is pulling up to a specific voltage or pulling down, there are definitely advantages and disadvantages associated with it. If we see most of the high speed designs that are there, and different logic levels that are used between driver and receiver, parallel termination is one of the commonly used termination in high speed designs. Mm, so this is all about high speed designs. Please let us know your comments. Please like our video and subscribe to our channel. Please post your questions, and we will try to answer them. Thanks for watching our video.